So this time, knowing how to multiply matrices, finding the determinant and the inverses, we can solve a system of equations without having to use row echelon form. So here's how we're going to do this. We're going to essentially take the system of equations and write them as matrices, like we kind of did with row echelon form. It's just going to have a different type of format. And then we're going to use the inverse matrix to solve. So I'm going to take the coefficients of everything on the left. So that is, move all of the constants to the right, get everything with a variable on the left, make sure that the columns add up, like the x's are in one column, y's are in the other. And I'm going to take the coefficients of these variables. So 5, -1, and then 2, 3, that's going to be my first matrix. And then I'm going to have a matrix next to that represents the variables. All right, we've got x and y, we've got two variables, and then I'm going to set this equal to the solution matrix. So what these equations are equal to, 21 and -12. Now here's how I'm going to write this. I'm going to call that A, I'm going to call that matrix X, and I'm going to call that B. And essentially we want to solve for X. We want to figure out what X is equal to. Now if this was an equation, looked like that, what would we do? Well, to get X by itself, we would divide by A, right? The problem is we don't divide matrices. We can only multiply them, and then even so, only like depending on the values of the size of the matrix and whether they add up or not. So instead of dividing matrices, we are going to use the inverse. So the way that we can solve for X is we can set X equal to the inverse of A times B. So using the inverse of a matrix is kind of similar to like division if we're solving for a variable. The important piece is that the inverse of A goes before B. If we don't put the inverse of A first, remember multiplication of matrices, the order matters. So the inverse of A needs to go first. Okay, so we've got to find the inverse of A. Once we've got that, then we can solve for X by multiplying that by B. First thing I need is the determinant of A. All right, the determinant of A is 5 times 3 minus -1 times 2. We've got 15 plus 2 here. Our determinant is 17. And then the inverse is then going to be found by taking the reciprocal of the determinant and multiplying that by the adjugate matrix. Okay, adjugate matrix of A, we switch A and D, and then we take the opposite signs of C and B. Looks like that. And now we multiply. So the inverse matrix is this kind of ugly looking one, where we've got those like hideous denominators there. Okay, so 17 is in the denominator. Okay, to get X, we are going to take this inverse matrix and we are going to multiply by B, which is 21 and -12. All right, do a quick check. This is a 2 by 2. This is a 2 by 1. The 2's match up. Our resulting matrix then will be a 2 by 1. So we know the final answer is going to be a 2 by 1, and that should match up to what X is. X is also 2 by 1. It has to be, so that we can have values of X and Y. All right, I'm going to work it out, and then we'll talk about the answer. All right, so I did all of the multiplication. I showed all the steps. Again, you can do most of it in your head if you can. So we get this final matrix, 3, -6. So what does that correspond to? Well, X in the system is 3 and Y was -6. So the final answer, the solution to this system, is the ordered pair 3, -6. Final answer. Okay, let's try one more. I'll do example 5, part A, and then you guys will finish the rest of this and check your work. All right, so again, we want to use the inverse to solve each system of equations. This time we've got this like variable B kind of included in there. We're going to take B as one of those coefficients. So when I set up the matrices that represent the system of equations, the coefficient of X is B, the coefficient of Y is 3, and then again B and 2. That's our first matrix. And then to that, we are going to multiply by X, Y, because those are the two variables we've got in this equation. And then our solution matrix, 14, 10, those are what the two equations are equal to. Okay, so this is A, this is X, this is B. To get X using the inverse, we take A inverse and we multiply it by B. So we've got to find a couple of things about A before we can solve for X. So let's talk about the determinant of A. The determinant of A, some of these things are going to be written in terms of B for this system. So the determinant of A is 2B minus 3B. So our determinant of A is negative B. So find the inverse of A. We're just going to take 1 over negative B, the reciprocal, and multiply by the adjugate matrix. So that is 2 and B get switched, negative 3 and negative B. The sign changes there. Okay, so we've got 2 over negative B, we get 3 over B, we get 1, and we get negative 1. That is the inverse matrix for A. Now, X is just that matrix times B. So we're just going to multiply this matrix by 1410. And let's see what happens. Okay, going across the top and down, we get 2 over negative B times 14 plus 3 over B times 10. And then bottom, 1 times 14 minus 1 times 10. All right, it looks like our final answer is going to be negative 28 over B plus 30 over B, and then 14 minus 10. Okay, so simplify that. We get 2 over B, and then we get 4. So X is equal to 2 over B. Y is equal to 4. Okay, that's the final solution there using the inverse matrix. Okay, try that last example. Negative 4x plus y is equal to 5. 6x minus 2y is equal to negative 9. Answer is posted on the class website. And then one last thing I want to talk about is that last example here, number 6. The book in this section is going to ask you guys to use the inverses in order to find the solution. But when you've got a 3 by 3, you've got 3 variables or more, it is really, really hard to find the inverse matrix by hand. So we're going to stick with variables, 3 or more variables. Just use row echelon form. So give that a practice. I'll put the answers to that one up as well. That one's a little bit long, but if you guys can do something like that with row echelon form, you're good to go. Email me if you've got questions. Good luck.